Hello, we're gonna present a solution to quiz number 15. In the first question, we're to find the derivative of two functions. So let's work on the first one. The first one, let's copy the question. Derivative of the given functions. And we have two of them. The first one, we got function y equals to x squared multiply e to the power of negative 1 over x. Okay. Well, when we want to find the derivative, which is dy dx. Okay. You can also write y prime. But dy dx is preferred notation. I wish you guys to get used to. So we're looking for the derivative of this product. Okay, if you treat it as FD, right? So you would let's put you like to have some scratch paper, right? So let me put down and think out aloud. So you have F and G. So this is F, this is G, right? So the derivative of product F multiplied G being taken derivative, and that would equal to the derivative of F multiplied G plus F times G derivative of G. So that's how you apply the product rule. And in this situation, F will be x squared and G is e to the power negative 1 over x. So you take a derivative of F is so 2x and G stay the same, right? And plus, and F stay the same. So we get x squared multiply e, the derivative of e to the power of negative of 1 over x. This is the place you get to use the chain rule, right? So when we use the chain rule on this piece, okay, when we work on chain rule on this piece, you will see that this as a u, right? The derivative of e to the power of, e to the power u with respect to u multiply u, right, dx. And of course, u is negative 1 over x. So that's how we apply the chain rule. And e to the power u differentiating with respect to u, right? We apply this formula, derivative of e to the power x dx here, e equals to e to the power of x. In applying this formula, what's important is not whether you use x or you use u, is the consistency between these two quantities. So if this is x, then the derivative of e to the power x will be e to the power x. If this is u, and that is u, and this is going to be e to the power u. If this is another symbol, say if this is a heart, and this is going to be heart, and then this is going to be equals to e to the power of heart, right? It's that consistency that's important. So on this piece and over here, you're going to get right under, right, the derivative of e to the power u with respect to u is going to be e to the power of u. And of course, u is negative 1 over x. So at this moment, so this e to the power u with respect to u is equal to e to the power u. We apply that. And since u is negative 1 over x, so you can substitute u by negative 1 over x here. And then you take a derivative of a negative 1 over x, which is going to be 1 over x squared. Okay, so how do we get that? Right? The derivative of negative 1 over x is equal to the derivative of negative x raised to the power of a negative 1 inside the parentheses. And here we can apply the derivative of x raised to the power n with respect to x equals to n times x raised to the power of n minus 1. Of course, once again, in this application, n is a constant. X is the variable, x raised to the power n. When these two are consistent, and the derivative of x raised to the power n equals to n multiply n to the power n minus 1. If we have a u here, and then there's a consistency, then go ahead, it's the same thing. And now we have a negative x raised to the power negative 1. The negative sign can be moved outside. So we will have the derivative of x raised to the power of a negative 1, and then with respect to dx. Okay, then we can apply this formula, and that's going to be, so we have an extra negative sign outside. And then we take a derivative of x raised to the power negative 1, and we apply this formula. So you have a negative 1, right? That's the n. And x raised to the power of a negative 1 minus 1. So that's how we got, because negative times negative 1, that's a positive 1. So we got x raised to the power of a negative 2. X raised to the power negative 2 is 1 over x squared. So that's how we got that. Okay, so when you show your work, you can just simply replace this part, okay, by this piece. And of course, if you want to write another line, that will be fine. And this piece will be replacing that piece. You still have an x squared here, okay? Some of you forgot that x squared. So x squared multiply the derivative of x raised to the power negative 1 over x. So this piece will replace that. And obviously we can reduce this part because this is multiplication. After reduction, we will have this piece reduced with that piece, and that's what we got. And if you like to write it as a product form, and that will be e raised to the power of negative 1 over x is factored out, you have 2x plus 1. So that's the answer. And as far as how much work you need to show, and this is how much work you can show. Any part of these, if you do want to show them, make sure they're not getting in between your major work. Okay, put them on the side, or on the scratch paper. As a reader, and this is enough for a reader. Okay, so I put it on Think Out Aloud. That's like, your scratch paper work. Okay, number 2. Okay, so let's look at number 2. Number 2, we got a function which is y equals to e raised to the power of sine 2x plus sine of e raised to the power of 2x. So we have a sum of two functions. So we're going to apply chain rule twice. Okay, we're going to apply chain rule twice. And we're also going to have, think out loud part. That's a scratch paper. So we're going to write it down, dy dx. Oh, sorry, never mind. Okay, so we're going to find dy dx. And that's going to be, we're going to take a derivative of this piece, right? You can, if you need a scratch paper, then you can write it down on scratch paper. And you can also show the work if you want. Okay, the derivative of dx. So you're going to treat this as a u. Okay, so the derivative of e to the power of u, and obviously u is sine 2x. So then you take a derivative and then there's a du dx. But u is sine 2x. Right? And sine 2x, that's a composite function as again. So you're going to simplify that part as, make 2x to be v. And then you make a dv. dv, and then you have a dv dx. So v is 2x. So if you apply chain rule, and that's the details of work, you can place this piece over here, or you can keep this in your, you mentally see that. You can write it as e to the power u, right? Because that's what you get from here, e to the power u, and you know what u is, right? U is sine 2x. So you can replace u by sine 2x, right? And then you work with the derivative of sine 2x. The derivative of sine v with respect to v, that's a cosine of v. But of course, you know what that v is. V is 2x. And last but not least, you take derivative of 2x, and that's going to be equals to 2. Okay. For the derivative of sine, okay, the derivative of the sine of e to the power 2x, right? So that's going to be your u. That's going to be the new u. Okay, so we're going to take a derivative of sine of u. And u obviously is e to the power 2x. Okay, so with respect to du, and then du with respect to dx. And u is e to the power 2x. But e to the power 2x, that's still a composite function. So you can make 2x to be v. So then you're going to make a dv, divide by dv, multiply by dv, and dx. Right? Hold on. And v is 2x. When you see the setup, right? When you see the setup, du, dv, dv, du, du, dv, they will be reduced. They will be reduced if you want to go back. You can go back, so you can check it. So with this in mind, you can either write it down, the entirety of it, or you just have that in your mind and show your work this way. The derivative of sine u with respect to u is cosine u, right? And what is u? U is e to the power of 2x. And the derivative of e to the power of v with respect to v, right? That's e to the power of v. And what is v? V is 2x. And last but not least, the derivative of 2x, that's going to be 2. Okay, if you want to show that piece of work, and you want to say, hey, I'm going to show this piece. That's fine. You can show that piece. You can show that piece, but just make sure you show it correctly. Okay, you just make sure you show it correctly. Okay, do you need to mark what is u, what is v in each cases? You don't need to. You don't need to, because the reader can tell from the comparison, right? E to the power of sine 2x here. So the reader can tell u is sine 2x. And v is 2x, right? So the reader can do that. But if you really want to, you insist on showing the reader, make sure you are clear about it. That's all. But this step is entirely optional as you are getting better. It's entirely optional. And the rest is just organize your work. It's just organize your work. Okay. So how do we write this down properly? I will put the 2 in front of it. Okay, so I'm going to write this down here. I'm going to bring the 2 to the front. And that should be fine. I can remove the dot, and that's clear enough. And the next one, I'm going to put the 2 in the front. And this piece is a little bit interesting because you don't want to remove the dot. If you remove the dot, it may be thinking this e to the power 2x times e to the power 2x. So it's better to put this e to the power 2x before cosine. So this will be clear and it's not going to cause any confusion. Okay, so when we write things down like this, you want to make sure that we don't cause any confusion or cause any ambiguity. The last question on this quiz is that find an equation of the tangent line to the curve. Okay, the curve is y equals to x multiply x times e to the power of negative x squared at a point which is 0, 0. And this point obviously is on the curve, right? If you plug in x equals 0, you're going to get y equals 0. All right, so how do we do that? Well, in order to find tangent line, we need to find the slope of tangent line. And the slope of tangent line can be found by taking derivative first. Okay, taking derivative, this is going to be a product rule. F, G. Okay, so the product rule, we have used it earlier, right? Right here. So think out loud. So in your mind, you need to know this formula. And you always have the flashcard. But by this time, I think you don't need the flashcard. But you need to know how to apply the product rule. So this is X, this is F, this other one is C. So F prime, right? Its derivative of X is 1. So 1 times e to the power of negative x squared. So that one, the first term is done. Plus, you don't have to write it 1 times, right? You can say, you can omit that. And then we're going to differentiate E, and then we're going to F times G prime. So F times G prime. So the derivative of E to the power of negative x squared dx, right? So this piece, we need to apply chain rule. We need to apply chain rule. So what will be the chain rule, right? It's a composite function. So this will be U, right? So you're gonna have derivative of E to the power of, let me just copy this whole thing here and put it here. Oops, sorry. Right here, right? So we're gonna make this U. And then we're gonna have it, so this is gonna be du divided by du multiplied by du and dx. And what is u? U is negative x squared. You see, that's applied the chain rule. And once again, the derivative of e to the power u with respect to u is e to the power u. And what is u? U is negative x squared, right? And multiply the derivative of negative x squared, that's going to be negative 2x. Don't forget the parentheses here. The parentheses here is absolutely necessary. If you miss this parentheses, you do lose point, okay? So the final answer is negative 2x multiply e to the power of a negative x squared, and that is for this piece, okay? You can put this piece in there, or you can just write it down like this. The derivative over here, that's e to the power negative x squared plus x multiply. So we're going to substitute what do we got here. Okay. Or you can just put this over here. It's okay. Okay. And next. We got the first piece, we don't have to do anything, plus x times negative 2x, that's going to be negative 2x squared. And then e to the power negative x squared. You can write it as a product form if you like, okay? So that's factored out. So you're going to have 1 minus 2x squared. That's it. The derivative is found. So now we want to find the slope of the tangent line at this point. So we have the derivative here, right? To evaluate, to have x equals 0, which will give us the slope. Let me write it down slower. So x equals 0. So the slope of this tangent line that we're looking for is the derivative evaluated at the point x equals 0. So that means that this entire function, this result, okay, is being evaluated at x equals 0. Okay, you learn how to use this notation. This notation is continue to be used in the future. Okay, and x equal to 0. So what does that mean? So this piece is going to replace all the x's by 0. So this is by 0, and that's by 0, right? And what do we get in the end? E to the power 0 is 1. So this piece is 0. So in the end, we get equals to 1. That's the slope. So slope equals to 1. And the line equation for the tangent line passes the point, a tangent line at, then we're going to use the same language, at 0, 0 would be y minus 0 equal y minus 0 equals to slope multiply x minus 0, right? Because the point, the x, the x, y is the same thing. So 1 and m equals to 1. So in the end, we get y equals to x. That's it. Okay. So what is the geometric meaning? Okay, we didn't ask you for it, but you can certainly do it, right? So if you have a graphing calculator, so you can graph it. Okay, so this is the graph of the function. Add 0, 0. Okay, add 0, 0. Where's 0, 0? Right, it's the point right here, 0, 0. So I'm going to put a dot right there. 0, 0. Make it a red dot. Right? Let's adjust the scale. Let's adjust the scale. I made some adjustment to the scale. So the scales in both directions are comparable. And the tangent line we know is y equals to x, right? So we're going to draw this tangent line. Let's make a different color. Blue. There we go. So that's the tangent line. Passes the origin. Okay. That's quiz number 15. I hope that helps. Thank you for watching.